Hello students, today we will study about the cube roots. So this is the topic of standard 8 chapter number 7 cubes and cube roots. So now we know that how to find out the cube of a number. Now today we have to study how to find out the cube root of a number. So we know that to find out the square root is the reverse process of the finding the square. In the same way, to find out the cube root is the reverse process to find out like 2 of the square cube, right? So this is what the reverse process to find out the cube, and that is cube roots. We know that the cube of 2, that is 2 cube, is equals to 8. So now what will happen if we apply this thing reverse process? Then the cube root of 8 will be what? It will be 2, and this is the what the sign of the cube root, right? In the same way that we are doing in the square, but here we have to put the 3. That means this is the sign of the cube root. Under root there is an 8, and that is represent the cube root of 8, and that is equals to 2. Now in the same way, cube of the 5 is what? 125. So the cube root of the 125 will be 5. So this is so simple to have to understand the cube roots. Now let us understand the methods to find out the cube roots. The first method is the prime factorization method. Prime factorization method we are also using to find out the square root. In the same way, here we have to apply the factorization. We have to find out the prime factors of whatever digit we have given. Okay, so let us find out the one of the example, that is 512. So when we factorize it, first of all we will divide it with the 2. So when we divide it with the 2, what we get here is 2 2s are 4, 2 5s are 10, and 12 is there. So we get 2 6 are 12, 256. Again divide it with the 2, we get 2 1s are 2, 2 2s are 4, and 2 8s are 60. Again divide it with the 2, we get the 6 2s are 12, and 4 2s are 8. Now again divide it with the 2, we get the 32. Again we get the 16. Again we divide it with the 2, we get the 8. Again divide it with the 2, we get the 4. 2 2s are 4, and 2 1s are 2. So this is the prime factorization of the digit 512. Now see, we can write down 512 as a multiplication of all these numbers, all these prime numbers, that you know now very well. Remember, in find out the square root, we are making the pair of the 2 same factors. Here we have to make the pair of the 3 same factors. So see, how many pairs we can make here? First pair, this is the second pair, and this is the third pair. How many pairs? 3 pairs of the same digit we have to make here. So when we write down it as a under root 512, sorry, cube root, right? Then from this pair we have to take one factor, from this pair we have to take one factor, and from this pair we have to take one factor, right? Now when we multiply it, 2 to the 4 to the 8. The answer is what? 8. That means the cube root of 512, the cube root of this digit 512 is what? 8. It is so simple, right? Like this. So now in the same way, let us find out the cube root of this digit. Okay. Now first of all we will divide it with the 2. So when we divide it with the 2, we get the 2 8s are 16. 1 is the remainder, so we get the 15. 2 7s are 14. Again 1 is the remainder, we get 16. 2 8s are 16. Now there is 1, we cannot divide it, take the 0. Now we get the 16, so 2 8s are 16. Okay, now again divide it with the 2. We get the 4. 2 3s are 6. 18. 2 9s are 18. 0 is there, we have to put the 0. 2 4s are 8. Now again divide it with the 2, we get the 2 2s are 4, 2 ones are 2. So 19 is there, 2 nines are 18. 1 is the remainder, 10 we get, 2 fives are 10 and 2 twos are 4. Okay, again divide it with the 2. We get the 2 ones are 2. Now 1 is there, we cannot divide, take 0. So now we have 19. 2 nines are 18. Okay, 1 is the remainder, 15 is there. So 2 sevens are 14. Again 1 is the remainder, 12 is there. 2 sixes are 12. Okay, now divide again with the 2. We get the 5. Here we get the 2 fours are 8. 1 is the remainder, 17 is there, so 2 eights are 16. Again 1 is the remainder, so 2 eights are 16. Okay, again divide it with the 2. We get the 2 twos are 4. 1 is the remainder, 14. 2 sevens are 14. 2 fours are 8. 2 fours are 8. Okay, again divide with the 2. 1. 2 threes are 6. 1 is the remainder, 14 is there. So 2 sevens are 14 and 2 twos are 4. Again divide with the 2. We get the 2 6 are 12. 1 is the remainder, 17 is there, 2 8s are 16. Again 1 is the remainder, 2 6 are 12. Okay, divide it with the 2. We get the 3 2s are 6, 2 4s are 8 and 2 3s are 6. Now see, the number is not divisible by the 2. So now we have to divide this number with 3. Right? Okay. So now we will do this process here. Now we will divide this 343 with 3. Right? Okay. First of all, let us check, can we divide it with the 3? 4 plus 3, 7. 7 plus 3 is 10. No, this is not divisible by 3. Again, it is not divisible by the 5. Can we divide it with the 7? Okay, let us check. 7 4s are 28. So what is the remainder we get is 6 and 6 and 3 63. Yes, 7 nines are 63. Okay, now 49 is again divisible by the 7. 7 sevens are 49. Again this is divisible by the 7 and that is we get the 1. Now see, make the pair of the same factors. Here we get the one pair of the same factor 7. Okay, how many 2 we get here is the first pair, the second pair and the third pair. Okay, now you know that we have to take one of the factor out of all these pairs. So here we can write down the cube root of the given digit 1 7 5 6 1 6. That is equals to 2 into 2 into 2 into 7. Okay, so what is the answer we get here? 2 2s are 4, 2s are 8, 8 sevens are 56. So the cube root of this digit is what? 56. Okay, so this is a very simple, very easy method to find out the cube root by the prime factorization method. Okay, now let us study some of the true false questions that is given in the question number 2 of exercise 7.2. So first question we have given is that cube of any odd number is even. No, this is statement false, because we know that the even number has a cube even and the cube of odd number is always odd. The second one is a perfect cube does not end with 2 zeros. Right? Perfect cube does not end with the 2 zeros. Yes, it is true, because if we find out the cube of the 10, we get the 1000. That is 3. In the same way, if we find out the cube of the 20, we will get 8000. So how many digits, how many zeros are there? 3. And 3 is what? The number of zeros are 3. So it will never end with the 2 0. So this statement is true. Third one is, if the square of a number ends with the 5, then its cube ends with 25. No, it is not necessary. This statement is false. Okay, one of the example you can take that it is possible in only the 5, because the square of 5 is 25. It is end with the 5. Cube of the 5 is also 125, and it is and with the 25, but it is the only case. After that, we cannot get the same thing. Okay, you can check the by taking the square of 50 and the cube of 50. Okay. Okay. Now the third one is if the square of a number. Okay, that we have already taken. See. Okay. Now fourth one. There is a no perfect cube which ends with 8. No, this statement is again false because one of the digit we have, that is 2, and its cube is 8. In the same way, you can also find out the cube of the 12, 22 and 32. They are all end with the 8. Okay, now fifth one is the cube of a 2-digit number may be a 3-digit number. This statement is again false, right? Because 2-digit number is what? Smallest 2-digit number is 10, and its cube is 1000, and 1000 is a 4-digit number. So there is a no number is possible with the 2-digit which has a cube, which the cube of the number has a 3-digit number. It is not possible. So the statement is false. Sixth one is okay. The cube of a 2-digit number may have 7 or more digits. This statement is again false because the 2-digit number can maximum have the 6 digit, right? This statement is false. You can check the cube of the 99 because the largest 2-digit number is 99. Okay. Now the seventh one is the cube of a single digit number may be a single digit number. Yes, the statement is true. Okay, there is no last 8th question. Only 7 true false statements are there. So the 7th one is right because single digit number is 1 and its cube is also 1. Single digit number 2 has a cube 8. So the 2 digits we have which are the single digit and its cubes are also single digit. So this statement is true. Okay, now let us study the question number 3. You are told that 1331 is a perfect cube. Can you guess without factorization what is its cube root? Similarly, guess the cube of the 4913 and 32768. Okay. So here we have to find out the cube root, but we know that to find out the cube root there is a method prime factorization, but we do not have to use here the prime factorization method. We have to estimate. We have to use the estimation method. Now see how to apply this method. Okay. First of all, we have to make a pair of 3 digits from the right hand side, right? So from the right hand side, if we make the pair of 3 digit, we get the 3 digit like this. Now what will remain here is 1. Put 1 more underscore upon that single digit. Like we are doing when we are finding the square root using the division method, what we are doing? We are making the pair of the 2 digits and putting the bar on the 2 digits, right? Here we have to make the pair of the 3 digits because we want to find out the cube root. Okay. Now, see this digit 331 and notice its unique place number. Unique place digit is what? Is 1. Now, you have to think about that which number has if we apply the cube root we get the unique digit as a 1, right? So there is only one digit is possible and that is 1 because the cube of 1 is 1. So here we get the 1 we get as a unit place number of the cube root of this number. Now what will be the tens place digit? That here we have 1. Now we have to think about that 1 is the cube of what digit? 1. So the tens digit place is also here we get is 1. So what digit we get here is 11. That means the cube root of this digit 1331 is equal to 11. Right? This is very simple method to find out the cube root and this method is called the estimate method. Let us apply the same thing here also. See, make the pair of the 3 digit. 4 is remain as it is because 4 is the single digit here. We make the pair of the 3 digit that is 930. Now think about where we get the 3 when we applied the cube. Unit place digit must be 3. So there is a number, there is a digit like 7. So 7 square is 49. If you again divide it with the 7, we get the 9 and 7. 9 sevens are 63. 3 we get as a unit place number. So here which number we have to put is 7. Right? Okay, now this is the 4. Now think about 4 is, if we take the cube of the 2, we get the 2 to the 4 to the 8. And if we take the cube of the 1, then 1 cube is 1, 2 cube is 8. So here this 4 is in between 1 cube and 2 cube. We can write down here is that 4 is in between 1 cube and 2 cube. Right? So from this we have to select the smallest digit out of 1 and 2. So out of 1 and 2 we have to select what digit? 1. So yes, this is the what? This is the cube root 4913. The cube root of 17 is cube root of this 4913 is 17. Okay, in the same way here also we have to apply the same thing, right? So make the pair of the 3 digit here and 2 digit here. Now think about the 768. The unit place digit is 8. Now remember, for what digit if we apply the cube we get the 8, that is 2, because 2 cube is 8. So the unit place digit in the cube root must be 2. Now 32. The cube of 3 is 27. The cube of 3 is 27. So this number is greater than the 27. And less than the cube of the 4, that is 64. 4 cubes. Right? We can also write down to understand it as a 27 less than 32 less than 64. Now see, the smallest digit out of 3 and 4 is what? That is 3. So the tens place digit here we get is 3, 32. So yes, we can say that the cube root of 32768 will be equal to 32. So the cube root by estimation method we have find out, and that is equals to 32. Simple thing is that we have to first of all make the pair of the 3 digit from the right hand side. Whatever the remaining digits, either 1 or 2 will remain the digit as it is. So we have to put down the one another underscore there. Now first of all estimate this 3 digit that we have make the first pair. From that first pair we get the first unit place digit of the square root. Right? So here we get the 1, because 1 cube here is the 1 and 1 cube is 1. That is why we put here 1. Here we can put the 7, because here there is a 7. Here there is a 3. So the cube of the 7 is 343, and 3 is there at the unit place digit. That is why we put here 7. And here 8 we put the 2, because the 2 cube is 8, and that is why we put 2 here. Now to get the unit place digit we have to check this number is in between which 2 cube numbers. It is in between, like 4 is in between the 1 cube and 2 cube, like 1 cube is 1 and 2 cube is 8. So this 4 is in between 1 and 8. From that we have to select the smallest digit. Here we select the 1, here we select the 3. And that is why in this way we can find out the cube root using the estimate method. So this is all about this lecture. Okay? Thank you.